So gauge transformations in electrodynamics. Okay, and till now what we have studied is that we first consider the significance of the term transformation in physics. Okay, and so that on the basis of this discussion we can build some basic idea about gauge transformations. Okay, so we have made some basic idea of gauge transformation on the basis of this discussion, that means the significance of transformation. And we have also found that these gauge transformations are basically some transformations of the electromagnetic potentials, that means the electric potential and the magnetic vector potential. Okay. After that we briefly recall about the basic structure of electrodynamics, and it is of course essential for us as this formulation of gauge transformation is made in electrodynamics. Okay, so we have briefly recall about the basic structure of electrodynamics. Now what we will do is that we have already seen that these gauge transformations are some kind of transformation of electromagnetic potentials. Therefore we must start with these electromagnetic potentials. But usually in electrodynamics what we do, we basically start with the electric field and the magnetic field. That means we start with the fields, okay, not the potentials. And after that we introduce about the potentials. That means after the study of fields we will introduce about the potentials. So what we will do, we will start with these the Maxwell's 4 equations we have already discussed, and these equations of course involve the fields, electric field and the magnetic field. Okay, so we will start with these Maxwell's equations, and after that we will introduce about the electromagnetic potentials. Okay, so this is the idea, and then after having the definition of electromagnetic potentials we will move forward. Here we will discuss about the electromagnetic potentials, that means the scalar potential V or the electric potential V and the magnetic vector potential A. Okay, and we will start from the Maxwell's equations, or in other words we will start with the fields, electric field E and B, magnetic field B. Okay, as these equations involve these fields E and B. Okay, so we will start with these equations and then we will define the potentials, electromagnetic potentials. So let us consider the Maxwell's equations. The first equation is divergence of E is equal to rho by epsilon naught. Then divergence of B is equal to 0. Curl of E is equal to minus del B del T. Then curl of B is equal to mu J plus mu epsilon del E del T. Okay, so these are 4 Maxwell's equations. Now let us consider equation 2, that is divergence of B is equal to 0. Okay. Now what we have is that this divergence of B is equal to 0 implies B is equal to curl of A. Okay. And this is actually followed from the mathematical principle that divergence of curl of a vector is always equal to 0, and this is we know from vector analysis. Okay, divergence of curl of a vector is equal to 0. So therefore divergence of B is equal to 0 means we can express B as a curl of some other vector. Okay, so that's why we can write B is equal to curl of A. Okay, and this vector quantity A is called the vector or magnetic vector potential. Okay, so in this way we can define the magnetic vector potential A, and we can express the magnetic field B in terms of the vector potential A, as B is equal to curl of A. Okay. Now come to equation 3 and 5. That means equation 3 and this equation 5 we have just formulated. Okay. What we have to do, we have to substitute this curl of A here in equation 3. Actually you have to work out this step in your pen and paper. Okay, then we get this equation, curl of what, E plus del A del T is equal to 0. That means from equation 3 and equation 5 we can easily arrive at this equation, curl of E plus del A del T is equal to 0. Okay. Now with this equation 6 we can again have some mathematical principle. We can apply similar principle from vector analysis, that curl of gradient is always equal to 0. Okay, that means curl of gradient of a scalar is equal to 0. So because of that, this vector quantity E plus del A del T we can express as a gradient of a scalar quantity. Okay, so that's why we have written this E plus del A del T is equal to negative gradient of some scalar quantity represented by V. Okay, and this is nothing but our scalar potential or dielectric potential, or basically we call it as scalar potential. Okay, so from this equation 6 we can express this quantity plus del A del T is equal to negative gradient of this V, and we can arrange this equation to express the electric field E as equal to gradient of V minus del A del T. Okay, so finally what we have done is that we have expressed this electric field in terms of the scalar potential and the vector potential. Okay, so in this way equation 5 and equation 7 we can express the fields E and B in terms of their corresponding potentials. Okay, so this is how we can define mathematically the potentials, scalar potential and the vector potential, that means the electromagnetic potentials. Okay. Now regarding the present study, that means the gas transformations in electrodynamics, we will be interested on these electromagnetic potentials V and A rather than the fields E and B, as we have already found that these gas transformations are some kind of transformation of the electromagnetic potentials. Therefore obviously we will be interested on these potentials. Okay, so from now on we will be considering these potentials only to continue our present study. We will not bother about these fields. Okay, and in fact it is also a well established knowledge that in theoretical studies we generally prefer scalar quantities, okay, instead of vector quantities. It is because to work with vector quantities it is generally cumbersome, so we prefer scalar quantities. So we can also consider this point from that point of view, that instead of E or and B we will choose, or we will consider the potentials V and A for or to continue our present discussion. Okay, it will be also good to mention here that in higher theoretical treatments we basically deal with these electromagnetic potentials rather than the fields when we have to consider about electrodynamics. Okay, and this we can find in higher studies like high energy physics. When we talk about electromagnetic field in high energy physics, there we will see that we will be basically dealing with these electromagnetic potentials when we have to work with the electromagnetic field. Okay, so anyway here we have defined these electromagnetic potentials, and now we will proceed with these potentials V and A to study the formulation of gas transformations.